Hello students, I am Tejaswini, lecturer in ENC, SJ Government Polytechnic, Bangalore. Okay. And today we are going to discuss I am going to give a lecture on branch instructions. Okay, branching instructions in 8051. In the previous sessions, we have already seen in some of the instructions of the 8051. Okay. So in this chapter, first you have seen about the addressing modes. What are addressing modes? What are the different types of addressing modes? Okay. So you have seen immediate addressing mode, register addressing mode, direct addressing mode. Okay, like that you have seen addressing modes. Then after that, we have discussed the instruction set. Like first we have discussed the data transfer instructions. Data transfer instructions means you'll be using the move. How you are going to move your data from one register to another register. In that you have seen different types of representation of the data transfer instructions. Then we have seen the logical instructions. In the logical we have seen this AND instructions, ANL, OR instructions, ORL, like that. We have seen the logical instructions. Then we have seen the arithmetic instructions. In the arithmetic instructions, we have seen the increment operator, decrement operator, how to use increment and decrement instructions, that is INC and your DEC. Then we have seen the add instructions, add with carry, then subtract instructions. Okay. Then we have seen the multiplication instructions, that we'll be using it as MUL, and the division instructions, that is DIV. Okay. Then after that we have seen the rotate instructions. Okay, that is we can rotate left or rotate right. Okay, RRL. Okay, rotate right instructions, etc. Then we have seen the exchange instructions also, XCH. That means the source data will be same, that will be copied to the destination address. Exchange instructions also we have seen. Now, in today's session, we are going to see what are the branching instructions. Okay, branching is nothing but your jump instructions. How many types of jump instructions are there? What are the ranges we are having? Jump means where it can jump. Okay, you can have, it can jump to a small difference range, or it can jump to long difference range. Understood? See, today we'll learn branching instructions, jump instruction ranges, and what are unconditional branch instructions. Understood? First we'll see what is branching instructions. What is branching? It is jump instructions. What is meant by that? Jump. A jump permanently, it changes the program flow, where areas call temporarily changes the program flow to allow another part of the program to run. See, in your program, if somewhere jump occurs, jump to this address means it will jump there. Then again it will continue. There only the program flow will be temporarily changed. Again it will come back to the place. Understood? Then in the jump instructions, it is classified into two types, unconditional jump and conditional jump. Unconditional jump. What is unconditional jump? The jump instructions which changes the program flow irrespective of the condition. In the unconditional, there won't be any condition. But in case of conditional jump, the jump instructions which changes the program flow if certain condition exists. Okay, jump if carry is not equal to 0, jump if carry is equal to 1, like that. If any condition is there, then we are calling it as a conditional jump instructions. We will see in detail. Okay. See, before going to see the instructions, okay, of unconditional, conditional, first we will see the jump instruction ranges. Understood? Jump to this particular address means where it will go. Understood? Jump and call instructions replaces the contents of the PC, that is your program counter, with new address and program execution to start from that new address. For example, if you give jump label, if you give the jump label means the label where it will be. So it will jump to the particular address of that label. Then your program counter address will be changed to the new address. The difference of this new address in program where the jump or call instruction is called range of jump or range of call. As I told you, for example, jump to the label. That means from where the particular address to where it is jumping, the difference between those byte, it is called as a range. Okay. See, we are having three different ranges. If you see the diagram here, in this we are having, see, from plus 128 to minus 128. It is relative limit. Okay, bit jumps and byte jumps, and this is your relative range. Okay, and then we are having SADD limit, that is short address limit. SADD limit means short address and LADD limit means long address. So the maximum range is 00002 to FFFF. Okay, we will see one by one. Jump and call instructions both will have three ranges. One is relative range, absolute range and long range. First one is relative range. Remember, relative range, it will be in the range of plus 127D to minus 128D. This is the range of the relative range. Absolute range. Absolute range means it will be within the page. The range will be 0000H to 07FFH. Next, long range. Long range will be 0000H to FFFH. Understood? Next, relative range. Relative range means what? The jump, it can be within minus 128 bytes or plus 128 bytes. It will be, the relative range will be in that range. If it is 0 to minus 128 range, then that you will be calling it as backward jump. If the jump is from 0 to 127 bytes, then we are calling it as forward jump. Understood? Jump and call instructions with relative range will be 2 byte instructions. Relative range, whichever the instructions are using the relative range, that will be of 2 byte instructions. The first byte, it will be your opcode, and the second byte is the relative address of the target location. That is where it has to jump. So, relative range is of 2 byte instructions. Understood? See, if you see the diagram, see, this is your relative range limit from minus 128D to plus 128D. See here, from PC, if it is from 0 to minus 128, then this is your backward jump. From 0 to plus 127, then it is your forward jump. Understood? And in general, the instructions that are used in the relative range unit will be generally it will be all conditional jumps only. That is jump JC, JNC, that is jump with carry, jump with not carry, okay, jump like the JB, JNB, JBC, we will discuss in detail. The conditional jumps that will be of relative range. Next one is your absolute range. In 8051, program memory is divided into logical divisions called pages, each of 2k bytes. So whatever the program memory we are having in 8051, we are dividing it and we are calling it as pages. Each page that will be of 2k bytes. So the maximum program size you can have is 64k. Already I have studied in the first chapter. It is of 64k bytes. So each page size will be 2k byte. Understood? So since the maximum program memory range is 64k, so how many pages you can have? That is 64 KB by 2 KB. That is each page is of 2 KB. Then maximum you can have is 32 pages. See 32. So page number 1, that is from 0000H to 7DOH, that is 2000D, since it is of 2k bytes. So next page you can have 71H to FA0H, that is 2001D2. This is 4000. Understood? See, this is in decimal and this is in hexa. Like that, 32 pages will be there in the absolute range. Understood? See, if you see in the diagram absolute range, see, this is your absolute range, this page. Okay. See, absolute range, it is from 0000H to 07FFH. Understood? Remember, it is of each page is of 2k byte. In the absolute range, it is also of 2 byte instructions. Understood? First will be your this one opcode and the next will be your address where you need to jump. Understood? Generally, the instructions here we are using is ACALL. Okay, absolute call instructions. Next one is your long range. What is long range? Long range means here the range will be from 0000H to FFFH, that is your 64K. Your program memory, the maximum size is 64K. So from 0 to 64K, it is called as long range. The jump and call instructions in this range, in the long range, it is of 3 byte instructions. Okay, in which the first byte it will be opcode and the second and third byte it will represent the 16-bit address of the target location. Okay, the first two, that is relative range and the absolute range, those two are of 2 byte instructions. First byte will be your opcode and the next byte will be of target address, that means where it has to jump. But in case of long range, it is of 3 byte address. So here it is a 3 byte instructions. First byte will be your opcode and the other 2 bytes will be your address of the target location. Jump and call instructions change the flow of the program by changing the contents of the PC. What your PC will do? Always in your program counter, it will be having the address of the next instruction that is to be executed. That is your program counter. Okay. So when you are calling the jump or call instructions, it will change the contents of the PC. Understood? ನಿಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ ಕೌಂಟರ್ ಅಲ್ಲಿ ಯಾವಾಗ್ಲೂ ಅದು ನೆಕ್ಸ್ಟ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಗೆ ಹೋಗ್ಬೇಕಲ್ಲ, ಅದರದ್ದು ಅಡ್ರೆಸ್ ನಿಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ ಕೌಂಟರ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಓಕೆ, ನೀವು ಯಾವಾಗ ನೀವು ಜಂಪ್ ಇಲ್ಲ ಯಾವ್ದಾದ್ರು ಒಂದು ಸಬ್ ರೂಟೀನ್ ಕಾಲ್ ಮಾಡ್ಬೇಕಂದಾಗ ನಿಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ ಕೌಂಟರ್ ಅಲ್ಲಿ ಆಟೋಮೆಟಿಕ್ ಆಗಿ ಇಟ್ ವಿಲ್ ಚೇಂಜ್ ದ ಅಡ್ರೆಸ್ ಆಫ್ ದ ಪ್ರೋಗ್ರಾಮ್ ಕೌಂಟರ್. ಅಂಡರ್ಸ್ಟುಡ್? So this is about your long range. Generally long range will be instructions like your lcall. Lcall is long call. Understood? So in the relative range, if you see the previous slide, so the relative range, it is from plus 127D to minus 128D, and absolute range, it is 0000H to 07FF, that is maximum of 2k byte, that is 1 page. So relative range alli neevu iveradunu, relative range and absolute range ಎರಡೂನು it is of 2 byte instructions. First byte ಅಲ್ಲಿ ಏನಿರುತ್ತೆ, ನಿಮ್ಮ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಹೆಸರು, ದಟ್ ಇಸ್ your opcode, ನೀವು ಏನ್ ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀರಾ, JC, JNB, ACALL ಆ ತರ ಇರುತ್ತೆ. Next will be the address, ನೀವು ಎಲ್ಲಿಗೆ, where you have to jump. Address means for example JB, next ಅನ್ನೋದು ನೆಕ್ಸ್ಟ್ ಎಲ್ಲಿರುತ್ತಲ್ವಾ ಅದ್ರ ಅಡ್ರೆಸ್ ಹತ್ರ ಅದು ಜಂಪ್ ಆಗುತ್ತೆ. long range, it is from 0000 to FFFFH. It will be of 3 byte instructions. First byte, that is your opcode irutte. Next 2 byte enirutte andre, that is the target of your location. Understood? But in case of absolute range alli ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ನಿಮಗೆ ಇದು this is of your as I told you, first will be opcode and the next will be your this one address. Understood? These are the 3 ranges that we are having in the 8051. Okay. Next, we will see the what are the unconditional branch instructions. What are the different instructions we are having in the unconditional jump instructions? Unconditional jump branch instructions means what? It will jumps to the specified address without any condition. ಯಾವುದೇ ಒಂದು ಕಂಡೀಷನ್ ಇಲ್ದಿರಾ ನೀವು ಸುಮ್ಮನೆ a jump to label ಅಂತ ಕೊಟ್ರೆ it will not see any condition. ಸುಮ್ಮನೆ label ಇರೋ ಹತ್ರ ಅಡ್ರೆಸ್ ಹತ್ರ it will jump there. Okay, condition ಅಂತಂದ್ರೆ ಲೈಕ್ ಕ್ಯಾರಿ ಈಕ್ವಲ್ ಇರಬೇಕು, 0 ಇರಬೇಕು, 1 ಇರಬೇಕು, ಈ ಬಿಟ್ 1 ಇರಬೇಕು, ಈ ಬಿಟ್ 0 ಇರಬೇಕು, ಆತರ ಯಾವುದೇ ಕಂಡೀಷನ್ಸ್ ಇರಲ್ಲ ಅನ್ಕಂಡೀಷನ್ ಬ್ರಾಂಚ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಅಲ್ಲಿ. ವಿತೌಟ್ ಎನಿ ಕಂಡೀಷನ್ it will jumps to the specified address. In the unconditional jump instructions, we are having 3 jump instructions. One is A jump, that is absolute jump. Next one is L jump, that is long jump. Next one is S jump, that is your short jump instructions. Okay. Next, we will see one by one. What is A jump? A jump is your absolute jump. Absolute, already we have seen. Absolute range means what will be the range? It will be from 0000H to 07FFH, that is 2K byte. It is of 1 page. So absolute jump, it will be within 2K block. So what is the syntax of the A jump? See here, this is A jump and code address. ನಿಮ್ಮ A jump opcode ಹಾಗೆ ಬರೀತೀರಾ. ಕೋಡ್ ಅಡ್ರೆಸ್ ಅನ್ನೋದು ಏನಾಗುತ್ತೆ, ನೀವು ಯಾವ ಅಡ್ರೆಸ್ಗೆ ಜಂಪ್ ಮಾಡ್ಬೇಕಾಗುತ್ತಲ್ಲ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಯಾವ್ದಾದ್ರು ನೀವು ಲೇಬಲ್ಸ್ ಅಂತ ತಗೊಂಡಾಗ ಇಲ್ಲಿ A jump next, ಓಕೆ, A jump to the label 1, ಇಲ್ಲಾಂದ್ರೆ ಅಡ್ರೆಸ್ ನೀವೇನಾದ್ರೂ ಸ್ಪೆಸಿಫೈ ಮಾಡಬಹುದು. ಸೊ ದ ಕೋಡ್ ಅಡ್ರೆಸ್. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಈ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಬಂದಾಗ ನೀವು ಇಲ್ಲಿ ಏನಿ ಟಾರ್ಗೆಟ್ ಅಡ್ರೆಸ್ ಇರುತ್ತಲ್ವಾ, ಈ ಅಡ್ರೆಸ್ಗೆ ಅದು ಜಂಪ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ A jump unconditionally jumps to the indicated code address. Okay, A jump is of 2 byte instruction. See, this is your opcode 1 byte and next this is your address. Okay, the new value of the PC, as I have told you, the program counter, the address of the program counter ಏನ್ ಮಾಡುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಯಾವ್ದು ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡ್ಬೇಕಲ್ವಾ ಅದರ ಅಡ್ರೆಸ್ ನ ಇದು ಸೇವ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಸೊ ಆವಾಗ ನಿಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ ಕೌಂಟರ್ ಅಲ್ಲಿ ನ್ಯೂ ಅಡ್ರೆಸ್ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ಈಸ್ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್ ಬೈ ರೀಪ್ಲೇಸಿಂಗ್ ದ LSB of the PC with the second byte of the A jump instruction. ನಿಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ ಕೌಂಟರು ಇಟ್ ಇಸ್ ಆಫ್ 16 bit. 16 bit ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, LSB that is from 0 to 7 ಏನಾಗುತ್ತೆ, ಅದರಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂತಂದ್ರೆ second byte of the A jump instruction. This is your second byte. ಅದರದ್ದು ಏನಿರುತ್ತಲ್ವಾ ಆ ವ್ಯಾಲ್ಯೂ ನಿಮ್ಮ PC ಯಲ್ಲಿ LSB ಅಲ್ಲಿ ಸೇವ್ ಆಗುತ್ತೆ. And replacing bits 0 to 2 of the MSB of the PC with 3 bits that indicate the page of the byte following the A jump instruction. ಇದರಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ 11 bits ಅಡ್ರೆಸ್ ಇರುತ್ತೆ, ಆಮೇಲೆ ಇನ್ನ 5 bits ಇರುತ್ತಲ್ವಾ ಅದು ಪೇಜ್ ನಂಬರ್ ಇರುತ್ತೆ. ಓಕೆ, bits 3 to 7 of the MSB of the PC remain unchanged. Understood? ಇದು MSB ಅಲ್ಲಿ 3 to 7. MSB ಅಲ್ಲಿ ನಾವು ಬರೀ 0, 1, 2 ಮಾತ್ರ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಅದ್ರಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂತಂದ್ರೆ ನಿಮ್ಮ ಪೇಜ್ ನಂಬರ್, ಇಟ್ ವಿಲ್ ಹೋಲ್ಡ್ ದ ಪೇಜ್ ನಂಬರ್. ಆಮೇಲೆ 0 1 2 ಆದ್ಮೇಲೆ 3 4 5 6 7 ಆ 5 ಬಿಟ್ಸ್ ಇರ್ತಾವಲ್ಲ ಆ ಬಿಟ್ಸ್ ಏನೂ ಚೇಂಜ್ ಆಗಲ್ಲ, ಹಾಗೆ ಇರುತ್ತೆ. ಇಟ್ ವಿಲ್ ರಿಮೇನ್ ಅನ್ಚೇಂಜ್ಡ್. ಸೊ ನಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ ಕೌಂಟರ್ ಅಲ್ಲಿ ನಾವು 16 ಬಿಟ್ಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ? ಓನ್ಲಿ 11 ಬಿಟ್ಸ್ ನ ಮಾತ್ರ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಈ 11 ಬಿಟ್ಸ್ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ? ಅಡ್ರೆಸ್ ಇರುತ್ತೆ, ಅದು ಎಲ್ಲಿಗೆ ಜಂಪ್ ಆಗಬೇಕು ಅನ್ನೋದು. ಅಂಡರ್ಸ್ಟುಡ್? ರಿಮೆಂಬರ್ ದಿಸ್. ಇನ್ ದ 16 bits we are using only 11 bits. The other 5 bits it will remain unchanged. Understood? So since only 11 bits of the PC are affected by the A jump, jumps may only be made to code located within the same 2k block as the first byte that follows A jump. So ಯಾವಾಗ್ಲೂ A jump ಅಲ್ಲಿ ನಿಮ್ಮ address that should be within the 2k, that is in the page, single page. Understood? Next one is your long jump. Long jump, what is the range of the long jump? The range of the long jump is 0000h to FFFFH. Okay. So ನಿಮ್ಮ long jump, what is the syntax here? ljump and code address. As I have told you, long jump, it will be of 3 byte instruction. First byte will be your opcode and the next 2 bytes will be the target address location. So long jump alli enagutte, without any condition it will jump to the specified address. Understood? Next one is your short jump, that is S jump. So what is the syntax here? S jump and then that is your relative address. So this is also 2 byte instructions. One is opcode and another one is target address location. So what it does? S jump, it jumps unconditionally to the address specified relative address. So ನಿಮ್ಮ relative address ಯಾವ range ಅಲ್ಲಿ ಇರಬೇಕು S jump ಗೆ? It should be of -128 or +127 bytes. Already we have seen. So the instructions that we can use here is JB, JNB, JC, etc. ಇದೆಲ್ಲ ನಿಮ್ಮ relative range ಅಲ್ಲಿ ಏನು ಬರುತ್ತಲ್ಲ ಅದೆಲ್ಲಾನು it is a short jump. Okay, same nim syntax S jump, relative address, ಅದರ S jump label, S jump next. Okay, ಈ ತರ ನೀವು ಏನಾದ್ರೂ ಎಲ್ಲಿಗೆ ಬೇಕಾದ್ರೂ you can jump. Okay. Next. See, in this session we have seen what are the different types of jump instructions we are having. That we have seen conditional instruction and also unconditional instructions. Conditionally you will be having the condition, then it will jump. But unconditionally enagutte, without any condition it will jump to the specified address. Then we have seen the ranges. What are the different ranges we are having in the 8015? That means where your jump or call instructions can go. We have seen the 3 different ranges. One is relative range, that is from -128 to +127. Then we have seen absolute range, that is from 0000h to 07FFH. Then we have seen the long range, that is 64k, from 0000h to FFFFH. Understood? Then again what we have seen, the unconditional jump instructions. In the unconditional jump we are having 3 different types of instructions. That is A jump, L jump and S jump. Okay. And this A jump and S jump are of 2 byte instructions and L jump is of 3 byte instructions. Okay. Now based on today's session we will solve some multiple choice questions. Okay. The first question. What is the relation between the target and the relative address? See, relation between the target and the relative address. Target address is equal to PC address plus relative address. Target address is equal to relation address to the power of 2. Relative address is equal to PC address plus target address. None of the mentioned. See, as I have told you, if any ಕಂಡೀಷನಲ್ ಆರ್ ಅನ್ಕಂಡೀಷನಲ್ ಏನೇ ಬಂದ್ರೂ ಕೂಡ ನಿಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ ಕೌಂಟರ್ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ಅದರಲ್ಲಿ ನಿಮ್ಮ ನೆಕ್ಸ್ಟ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಯಾವ್ದು ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗ್ಬೇಕಲ್ಲ ಅದರ ಅಡ್ರೆಸ್ ಇರುತ್ತೆ, ರೈಟ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೀವು ಈಗ ಎಸ್ ಜಂಪ್ ನೆಕ್ಸ್ಟ್ ಅಂತ ಕೊಡ್ತೀರಾ, ಅವಾಗ ನಿಮ್ಮ ಪ್ರೋಗ್ರಾಮ್ ಕೌಂಟರ್ ಅಲ್ಲಿ ಏನಾಗ್ಬೇಕು, ಪ್ರೋಗ್ರಾಮ್ ಕೌಂಟರ್ ಅಲ್ಲಿ ಇವಾಗಿರೋ ಅದು ಎಲ್ಲಿದೆ ಅಡ್ರೆಸ್, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅದು 2000 ಅಲ್ಲಿ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. 2000 ಪ್ಲಸ್ ರಿಲೇಟಿವ್ ಅಡ್ರೆಸ್, ನೆಕ್ಸ್ಟ್ ರಿಲೇಟಿವ್ ಅಡ್ರೆಸ್ ಏನಿರ್ಬೋದು, ಸಮ್ 30H ಅಂತ ಇರ್ಬೋದು. ಅವಾಗ ಏನಾಗುತ್ತೆ ನಿಮ್ಮ PC ಅಲ್ಲಿ 2000 ಪ್ಲಸ್ 30 ದಟ್ ಈಸ್ 2030H ಅಡ್ರೆಸ್. ಸೊ ನಿಮ್ಮ ಜಂಪ್ ಎಲ್ಲಿ ಹೋಗ್ಬೇಕು, 2030H ಗೆ ಜಂಪ್ ಆಗ್ಬೇಕದು. ಸೊ always in the target address you will be having your PC address plus relative address. Option A is correct. Which type of branch instructions jump to a novel location from the continuation of the previous program upon its execution? So ನಿಮ್ಮ ಬ್ರಾಂಚ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಅಲ್ಲಿ ಕಂಟಿನ್ಯೂಷನ್ ಅದಾದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಏನ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗುತ್ತೆ, ಡೇಟಾ ಟ್ರಾನ್ಸ್ಫರ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್, logic instructions, bit oriented instructions, unconditional instructions. That is unconditional instructions. Which among the category of program branching instruction allows 16-bit address to be specified and can jump anywhere within 64K block of program memory? Yavadu 64 block? L jump, S jump, A jump or all of the above? I have already told you it is long jump. In the long jump, you will be having the range from 0 to 64K. If the MSB, that is most significant bit of relative address byte is 1, then the short jump instruction, it is forward jump, back jump, either forward or backward, none. ನಿಮ್ಮ MSB of the relative address byte 1 ಇದ್ರೆ short jump instruction ಯಾವುದು, it is back jump. The first byte of the absolute jump instruction consists of, absolute ಅಲ್ಲಿ first byte ಏನಿರುತ್ತೆ, I have already told you. See, option A, 3 LSBs of opcode and 5 MSBs of 11-bit address, 5 MSBs of opcode and 3 LSBs of 11-bit address, 6 MSBs of opcode and 1 LSB of 11-bit address, 5 LSBs of opcode and 3 MSBs of 11-bit address. First byte ಅಲ್ಲಿ ಏನಿರುತ್ತೆ, ನಾನು ಹೇಳಿದೀನಿ ಫಸ್ಟ್ ಬೈಟ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಫ್ರಮ್ 3 bits, ನಿಮ್ಮ 11-bit ಅಡ್ರೆಸ್ ಅಲ್ಲಿ 3 bits ಏನಿರುತ್ತೆ, 3 MSBs of 11-bit ಅಡ್ರೆಸ್ ಇರುತ್ತೆ. The other 5 bits, that is from 3 to 7, ಈ 5 bits this is of opcode. ಓಕೆ, ಅರ್ಥ ಆಯ್ತಾ ನಿಮಗೆ? ಈ 2 bytes ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, 2 bytes ಅಲ್ಲಿ 11 bit ಅಡ್ರೆಸ್ ಇರುತ್ತೆ, ಇನ್ನು ಅದರ್ 5 bits opcode ಇರುತ್ತೆ. ಓಕೆ, the third byte of the long jump instruction is opcode, 5 LSBs of the opcode, higher byte of jump location or subroutine, lower byte of jump location of subroutine. The third byte of the long jump, third byte ಅಲ್ಲಿ ಏನಿರುತ್ತೆ, will be having the higher byte of jump location or subroutine. Okay, so ಎಲ್ಲಿಗೆ ಅದು jump, ಯಾವ byte, higher byte ಇರುತ್ತೆ ನಿಮಗೆ. Okay, next, the absolute jump instruction is intended mainly for a jump within the memory space. Absolute jump instruction memory range is to 2 bytes are 2k bytes, 2m bytes, none. It is of 2k bytes. Okay. So today we have discussed the jump instruction, that is ranges and unconditional instructions. I hope you understood today's session. Okay. Thank you.